tackle heap sort. First, we're gonna tackle heaps and how we can build a max or min heap, and we will discover what is a max and what is a min heap. We're gonna discover a process called heapify, which will help us in heap sort. We're gonna go over heap sort and try to sort an array using heap sort, and finally, we're gonna see the code for the heap sort. What is a heap data structure? A heap data structure is a complete binary tree where it has all its levels full except possibly for the last level of the tree, where the nodes on the last level of the tree are starting to fill out from the left side of the tree and not the right side of the tree. For example, this is not a heap data structure. Why it's not a heap data structure? Because here all the levels are full. However, in the last level, there should be a node pointing here. We have a node missing here, so it is not a heap data structure. If it were like this, the pointing node here is pointing first to the left node, not the right node, it would be a heap data structure. Here we have a max and a min heap data structure. So what is a max heap and what is a min heap? A max heap is a heap that has a parent always bigger than its children. For example, 40 is bigger than 20 and 17, and the rest follows. Like 20 is bigger than 3 and 2, and 17 is bigger than 5. Every parent is bigger than their children. A min heap data structure is vice versa. The parent is always smaller than its children. Here 3 is less than 10 and 9. And 10 is less than 12 and 11. Also, both are heaps because both are complete trees where all the levels are full and the last level is filled beginning from the left side of the tree. The fun thing about heaps is that we can transform every possible array into a heap data structure. We can start filling the heap level by level until there are no elements left out in the array. For example, if you want to transform the array A into a heap data structure, start by adding 7 as the root, cross 7, now 3. We start filling each time from the left side of the heap. Now this is the heap for the array A. Let's say you have managed to transform your array A into a heap data structure, and you want to get the position of a certain children of a parent. Or you want to get the position of a parent from a certain child. How shall you do that? Given the position of a parent here, you can calculate the position of the left and the right children. For example, let's say the parent is 3. The position of 3 is 1. So 2 times 1 plus 1 is 3. At index 3 we have 5, so 5 is the left child. The same goes for 4 because it is the right child of 3. Now let's say you want to get the parent of the element 1. 1 is positioned at 2, so 2 minus 1 is 1. The floor of half is 0, so 7 is the parent of 1. You're asking the question, why should we transform the array A into a heap data structure? A heap data structure follows a tree data structure. And inside the tree data structure, most of the methods and the functionalities are done in dog and time. So, transforming the array A into a heap will let us be more efficient in using timed complexity. Now, in order to sort the array A using heap sort, we follow these processes. First, we build a max heap. You can also build a min heap, but in this video, we're going to focus on building a max heap. Once we build a max heap, the root element of the max heap will become the greatest element of the heap. So we managed to pop this element, place it at the end of the array, and find the next greatest element using heapify. So after each iteration and after placing each element at the end of the array each time, we reheapify and found the next greatest element until the heap is empty. I'll manage to share the code with you later in this video, but for now, let's simulate a heap sort algorithm on the array A. So in order to build a max heap, we start iterating backwards from the elements that have only children. so we exclude the leaf nodes of the heap. We compare the parent element with its children. If the parent element is smaller from its children, we swap the child with its parent. For example, here 21 is less than 28, so we swap them. We continue iterating to 20. 40 is greater than 20, so we swap them. Now, 28 is greater than 5, so we swap 28 with 5. After swapping 28 with 5, we repeat the same process for the element that we swap it with. To find that 21 is greater than 5, so we swap 21 with 5. We managed to do this process recursively. Now we reach the parent element. We found that 40 is greater than 7, so we swap 40 with 7. And 20 is greater than 7, so we swap 20 with 7. Now 40 is the greatest element of the heap after using this process to build a max heap. So we managed to pop 40, place it at the end of the array, and reheapify again to find the next element. How do we do that? We first managed to place 40 at the last element, exclude 40, 5 now becomes the new root, and reheapify to find the new greatest element. So now we placed 40 at the end of the array. The heap now becomes this part excluding 40. We managed to reheapify, and how will we reheapify? We compare the parent element with its children and repeat the same process. Now let me simulate the rest of the algorithm. After simulating the algorithm, we have managed to sort the array using heap sort. In particular, first building a max heap and then reheapifying after placing the greatest element at the end of the array. Now what about the time complexity of heap sort? The build max heap takes big O of n, since we are iterating backwards from the non-leaf nodes of the array, and at each iteration there may be recursive calls to continue the process of building a max heap and heapifying. The heapifying process alone takes log n time, since we are traversing from the root of the tree to the bottom of the tree, so the height of the tree would be log n. But we are doing this heapified process for every element of the array, so the overall time complexity of heap sort will be n log n.
Guys, here's the code for the heap sort algorithm. First, the main method is heap sort. It builds a max heap, and first builds a max heap. So the build a max heap algorithm is here. It takes a vector a and an integer n representing the length. It traverses through the nodes that only have children, so it excludes the leaf nodes. Calculates that by getting the middle, flooring it, and iterating backwards from the middle to 0. At each iteration, it calls the max heapify algorithm, which is the algorithm I discussed. It first gets the left and the right children. It assumes that the parent is the largest. If any of its children is bigger than the parent, it swaps the two nodes, and then it recursively calls the same method if it swaps any of the parents of the children. So after building a max heap, we have the root element as the main, as the greatest element. So it manages to swap this root element with I, which is at the end of the array. Here we are iterating from n minus 1. And then it recalls a max heapify, but from 0 to I. So to exclude the last element, which is now in its correct position. So let's try this algorithm. First, we enter the length of the array, let's say 5. As you can see, here is the sorted array. We'll share the code with you in the description, and this has been the code for Heapsort.
This has been the CS Tutor. Thank you for watching. If you have any question, put them down below and see you next time.